Okay, good morning. I'd like to get started, please. First of all, I'm anxious to know how's your orange juice doing. Okay. Took your losses, huh? I think it's still down, right? Yeah. Okay, today I'd like to continue our discussion of Chapter 3. And we started on Monday with the discussion of storable markets, and we talked about the linkage between spot and futures markets. Today I want to continue with that. I need your attention, please. Thank you. I can't, my voice is not that strong to shout over everyone. So today we want to talk about the theory of intertemporal prices. And we want to talk about the theory of normal backwardation. Theory of normal backwardation and the theory of price of storage. These are essentially the two main conceptual models that explain how prices for different delivery months are related, and in turn how they are related to the spot price. The theory of normal backwardation was developed by a very famous economist, John Maynard Keynes, and it's somewhat simpler than the theory of price of storage, which was developed by an economist by the name of Holbrook Working. It's not as though the two are inconsistent. They're actually consistent with one another. And we'll go through each of them step by step. So the theory of normal backwardation basically argues that futures markets are set up for hedging purposes. Basically, the markets are set up for hedgers. Keynes believed that hedgers are net short. So the implication is speculators are net long. And what does this mean? Well, it simply means that if you take all the hedgers in the market, some of the hedgers have long positions, some have short positions, but typically the number of short positions exceeds the number of long positions. So normally hedgers are selling. It's not as though hedgers don't also buy for price protection, but normally they're selling. It means that speculators are net long. He assumed that speculators are risk averse. Speculators are risk averse. Just like our friend in the back who sold his orange juice. He's had enough, he's risk averse. Another way of interpreting this assumption of risk aversion, and we'll talk about a formal definition of that next week, but essentially it means that if you're speculating in the market, you're investing to earn a profit, and you're not going into this market with the expectation of a negative return or a zero return. You're trying to make a profit. So you're risk averse. And the third assumption is that speculators cannot forecast prices. So on average, speculators cannot exactly predict where the market is going. So in essence, what this theory assumes is that speculators are selling insurance to hedgers. The hedgers are net short, speculators are net long. So if you're a hedger and you're selling futures contracts, I'm a speculator, I'm buying futures contracts, I'm risking my money by going long. You're trying to protect a position you have in the cash market by going short, so I'm selling you insurance. And I charge a premium for that. It's called a risk premium. So according to this theory, let's suppose that this is days to maturity on a futures contract. Okay, so it could be the March contract, the January contract, doesn't really matter. So here's 0, so the contract expires when it gets down to 0, okay? And suppose we're 100 days out from maturity. In other words, 100 days prior to expiry of the contract. If today's cash price, if the cash price is sitting at this point, and let's suppose that this is $2.50, so this might be a corn contract. So the current cash price is $2.50. Then as we approach maturity, as we saw on Monday, we simply expect this cash price, to rise by the cost of storage, okay? So rises by the cost of storage. So on Monday, when we looked at this relationship, we had the cash price sitting at $2.50. If the cost of storage is 50 cents for 100 days, then it would rise to $3 if nothing else changed. But as you know, this is a snapshot in time. This whole market could move up or down. So if the speculators were not charging a risk premium, then what price would they be willing to pay for the futures contract if they're going long? In other words, I'm a hedger. You're a speculator. Today's price is $2.50. We know that the carrying costs are 50 cents, so it's going to rise to $3. I'm trying to sell a futures contract that's deliverable on day 0. So I walk into the pit and I say, well, I want to sell it for $3.50. Would you buy it? Probably not. Okay, I'm going to have to remind you guys, please come to class on time, okay? It's very distracting for everybody. Thank you. So why wouldn't you pay $3.50? I want to sell it for $3.50. You can get the cash for $3? Well, the cash is $2.50 right now, okay? But you're right. You could buy the cash now and hold it for 100 days. So if I tried to sell it for $3.50, you'd just turn your back and walk away. Suppose I tried to sell it for $3. Would you buy it? Again, I'm the hedger. I'm the hedger. I'm in the pit. I'm trying to sell this contract for $3, and I'm pushing it up against the wall. I want to sell it for $3. Are you going to buy it? No? Why not? You're not going to have a profit because that's what you're going to sell it for, because we expect the price to be $3. So that's right. Why would you pay $3? If you're risk averse and you're trying to make a profit, you wouldn't pay $3. So again, you turn your back away. So I have to keep lowering the price, right? As a hedger, I want to sell it for the highest price. I tried $3.50, you said no. I tried $3, you said no. So what if I offered it for $2.90? Come on. $2.90. Anybody buy it for $2.90? Yes? Okay, sold. All right. He says $2.90. So he'll buy it for $2.90. So this is the futures price, $2.90. Thank you. Which means that he's paying less than the expected spot price at maturity. The expected spot price at maturity is $3. It's up here. So the difference we call a risk premium. The difference is a risk premium. That's what I have to pay for insurance. I'm selling the contract to buy insurance. I can't sell the contract for the expected spot price of $3. I have to sell it for a lower price. And when you're selling, the higher the better. So I sell it for a lower price at $2.90. which means there's a risk premium of 10 cents. Another implication is that the futures prices will rise as we approach maturity, rise relative to the expected spot price. So our speculator friend in the front row here will make his 10 cents. At least he's expecting to make 10 cents. Things could change tomorrow. But that's the implication of the theory. So it basically argues that the cash price is determined by supply and demand in that market. And it argues that the futures price is equal to the expected cash price minus the risk premium. Okay? That's the theory of the price of storage. I can see I'm going to have to clamp down. Sometimes being nice doesn't work. Any questions on this basic conceptual explanation for the relationship between cash and futures or two different futures months? According to this theory, when you look at the futures price, $2.90, that's a downward biased estimate of the forthcoming cash price. That's why it's called the theory of normal backwardation. It's a downward biased estimate. It's not a perfect estimate. We said earlier in the class that we can view the futures price as a prediction of the forthcoming cash. Keynes would say, no, it's less than the forthcoming cash by the size of the risk premium. Now, whether a risk premium exists in the markets is still a debatable point. People have tried to measure it and found that it might exist, but it's quite small. If it's quite small, that tells us that speculators are willing to sell the insurance for a low risk premium. So it's a competitive market. There are a lot of speculators. They're willing to sell it for a small premium. Okay? So let's move on to Working's theory then. It's more comprehensive, and he basically believed that the cash and the futures are not autonomous, that they're determined together. And rather than the futures market existing for the purposes of allowing hedgers to buy insurance, Working said that intertemporal prices reflect supply and demand for storage. Supply and demand for storage. So he focused on the market for stocks. It's not storage space, but it's actual level of inventories that he focused on. And he started by writing down a very straightforward arbitrage condition. He said that the futures price at time t for delivery in period t, so this is the futures price today, where today is lowercase t, for delivery at some future date, which is capital T, is equal to the spot price today, plus the cost of plus the opportunity cost of the money that you have invested in the spot commodity from time t to t, plus the warehouse cost, we'll call that W, over this time period. And then he added another term, and he called that convenience yield. So this is futures price at time t for delivery at capital T. ST is the spot price. R sub t is basically the cost of money. You can view it as the interest rate, because if you're holding the spot commodity, you must buy it, and so your capital is tied up in the inventory, and you can't use that capital elsewhere. So R of t is the cost of money. W of t is the warehouse cost. So this is like the physical inventory cost, such as insurance and all the other costs that go along with physically holding the commodity. And C of t is something called the convenience yield. Convenience yield, which is actually a negative cost. The convenience yield is a negative cost. The convenience yield is a return associated with holding the physical inventory. It's a negative cost, and I'll come back to that in a second. So that's your standard arbitrage equation for a storable commodity. It turns out it also applies to financial instruments that are storable, such as treasury bonds. This applies to any storable commodity, crude oil, corn, wheat, etc. So if this arbitrage condition holds, then we have an equilibrium situation. In other words, the futures price reflects the current spot price plus the cost of holding that inventory minus any convenience yield. However, if the futures price was greater than the spot price plus the cost of money invested in the spot market plus the warehouse cost plus the convenience yield. If that's the case, then there's an arbitrage opportunity. Then there's an arbitrage opportunity. It's just like if, when I go to the coffee house in the morning and there's a long line in the small coffee area, I go around the corner and find the shorter line, there's an arbitrage opportunity. I'll take advantage of that. If the futures price is greater than the cost of holding the spot minus any convenience yield, then what you do is you buy the spot and sell the futures, as you said earlier. For example, let's just set the convenience yield equal to 0 for the time being. Okay? So if that's the case, let's say that the spot price is $2.90, and let's add the cost of the money tied up in this inventory at 5 cents. Okay, and we'll call that R sub t. And let's add warehouse costs of 10 cents, and we'll call that WT. So this is equal to $3.05 if that arbitrage condition holds, and we just set the convenience yield at 0. So if that's the case, then there's no arbitrage opportunity. But let's suppose that the futures price was $3.20, okay? And these other costs remain the same. Then what sort of arbitrage activity kicks in? The futures happen to be trading at $3.20 all of a sudden. Spot is still at $2.90. What would you do as a trader? Buy what? That's the right answer. Buy what, though? Who said buy? Somebody said buy. Come on, I'm giving you half the answer. There's an arbitrage opportunity. The futures price was trading at $3.05. Now, boom, it's at $3.20. The spot price hasn't changed. The costs of holding haven't changed. What do you do? This is no more difficult than if I took you and I showed you, here's a long line for coffee. Here's a short line for coffee. You walk into the room. Which line do you get in? Okay? Give it a try. Thank you. You buy spot at $2.90. It's going to cost you 15 cents to hold it. You sell the futures at $3.20, and you've earned a riskless return because the futures price is greater than the spot plus the cost of holding it. So if the futures price is at $3.20, you buy your spot, you incur your costs, you sell your futures, and deliver on the contract. And you earn a 15-cent return. Yes? It's 250. Okay. The numbers I'm using here are a little different than the graph, but yeah, the concept is the same. The spot price is whatever it's going for now for immediate delivery. Okay, it's the same as cash price. Okay, so you buy at $2.90. You're prepared to incur the 15-cent cost, which is $3.05. You sell it for $3.20 on the futures. You hold it for whatever period of time we're referring to, 100 days, and you deliver on a futures contract. And you get your $3.20, so you've made 15 cents a bushel. It's easy money, right? There's no risk. Now, what if everybody started doing the same thing? What happens to the spot price? It goes up. What happens to the futures price? It goes down. Everybody's buying spots, selling futures. They're going to come back together until we end up with an equality again. Okay? Until we end up with an equality where there is no arbitrage opportunity. So that's basically what underlies the working argument, is that this arbitrage opportunity works because there's a lot of warehouse space around. If we're talking about grains, if we're talking about oil, there's plenty of storage space. There are plenty of merchants who are willing to buy the commodity and store it as long as they earn a reasonable return. And whenever that return gets to be above what's considered normal profit, then arbitrage kicks in and you have the prices coming back in line according to this arbitrage equation. Okay? So let's talk about convenience yield, unless you have some questions on what I've just covered here. I'm still having trouble assessing whether you're bored, you've already read the chapter, you understand what's going on, or you don't have a clue, or we're in equilibrium. But the chances of being in equilibrium are probably low. Okay, we have an arbitrage opportunity here. I know the material, and some of you don't. So you just need to get in line and ask questions. Convenience yield. It's a controversial term. It's a negative cost. Okay. If the futures price is less than the spot price plus the cost of carrying the spot, if the futures price is less than the spot price plus the cost of carrying the spot, then that implies that there's convenience yield. That implies convenience yield exists. And the convenience yield, C sub t through time t, will equal the spot price times the cost of carrying the spot price plus the warehouse fee minus the futures price. So for example, if we said the the spot price over here we said was 290. Okay, so the spot is 290. We said R is 5 cents. And we said W is 10 cents. And if we set the convenience yield at 5 cents, okay, then we have the spot, which is 290, plus 5 cents, plus your 10 cents, which gives us 305. If the futures price is only $3, then we have a convenience yield of 5 cents. The convenience yield is a return. We throw it in on the cost side, but it's actually a negative cost. It's a return associated with holding the physical inventory. And there could be a number of reasons why there's a return associated with holding the physical inventory. The simplest example I can think of is that of keeping money in your pocket versus keeping money in the bank. It's a little easier these days to arbitrage that decision because we have ATM machines all over. Right? When I went to college, there was no such thing. To get money out of the bank, you had to go downtown, stand in line. It took forever. So you tended to carry more cash around. In any case, most people walk around town with some cash in their pocket. Might depend how rich you are, right? There's this famous guy, Mike Milken, who made billions trading junk bonds. He used to walk around with $10,000, $20,000 in his pocket. I assume most people walk around with smaller amounts. But why do you do that? Why do you carry money in your pocket? Because you're not earning any interest. Why not leave it in the bank, and every day you go down to the ATM machine? Well, there are transactions costs associated with that. It's inconvenient. So the money in your pocket is actually generating a yield. It's a return associated with the convenience of having it. And that's why you're satisfied to keep that money in your pocket and earn no interest. It seems irrational. You would think that a rational person would keep every single dime in the bank and then go down and draw the money out as you need it. Okay? Now, I see some people writing a check for a cup of coffee, which drives me crazy when I'm standing in line. So maybe they're rational, and I'm not. But it takes time to write a check, too. So, but that's an example of convenience yield, sort of. Another more pertinent example to what we're referring to might be the practice of some of these large food manufacturers of holding inventories to keep their plants running for fear of a stockout. And a prime example is Anheuser-Busch. Right? They make Budweiser beer. You all watch the commercials. You know it's the king of beers. Anheuser-Busch spends millions, tens of millions a year advertising this product. They spend a lot of money convincing you that it tastes better than the competitor. In order to ensure the quality of this product, they must have homogeneity with regard to their inputs, high quality inputs. And one of the major inputs into the king of beers is barley. It's malting barley that grows up in Montana and Minnesota and up in that region. But that crop is only harvested once a year, and the weather can have a huge impact on the quality of the crop. If there's a lot of rain in August or September, the quality goes down. August Bush III can't buy sufficient high-quality barley. The quality of Budweiser goes down, and you know what happens. He gets upset, they lose money. It's not a good idea. So what does Anheuser-Busch do in the face of this situation of this uncertainty every year with regard to stocks of high-quality inputs? What do you suppose they might do? What do they do?
They set the bar on
Set-
inputs.
No, no, they don't do that. Inventory? Pardon? Inventory of barley, exactly. They carry a year's supply. They carry a year's stock of barley, which costs them money to store. Obviously, it's not cheap. They have to build these facilities. But it also generates a convenience yield, because if there's poor weather and they're unable to buy barley of sufficient quality, it's okay, they've got it in stock. So they carry large inventories that generates them a convenience yield. Okay? Exciting example, right? I think I'm going to have to start telling jokes to get your interest. Anyway, that's an example of what convenience yield is. It's really a negative cost. So if you look at the cost of Anheuser-Busch holding its barley, you might cost it out and say, well, you know, it's costing us 50 cents a bushel to hold this inventory from year to year. It's not worth it, right? Because we could just go out and buy the barley. Well, in theory you can, but if there's a poor crop, you can't. And obviously in their case, the convenience associated with having access to it, no matter what happens to the weather, exceeds that physical cost. Okay. So now, working started to put this information together. We have this arbitrage condition. That's how the market works. And he was interested in the following relationship. S sub t stands for the volume of stocks carried out of period t. Okay, so we have two different time periods. We have period t and period t plus 1. So the price in period t plus 1 minus the price in period t is an intertemporal price spread. T plus 1 could be March futures. T could be January futures. Doesn't really matter. T could be the spot price. T plus 1 could be January futures. So we have a price for two different time periods. S sub t is the volume of stocks that's carried from this period to the next period. So he believed that this intertemporal price, and after all, that's what we're talking about, is the spread in the futures market. He said it depended on the demand and supply for stocks. So we have to derive the demand and supply for stocks in order to see if he was right. So let's start with an equation you're all familiar with. The price in period t is a function of consumption in period t. Okay? That's an inverse demand curve. In fact, I could put a subscript t on this. So if we differentiate this expression with respect to consumption, we'll find that it's negative. That's just your typical demand curve, right? The law of demand says that if you lower the price, demand goes up. If you raise the price, demand falls. It's a downward sloping curve. So that's where we start. We also know that consumption in this period is equal to stocks coming in. So stocks coming in will equal stocks that were carried from the previous period, st minus 1, plus production, x sub t, minus stocks carried out. So ct is consumption. St minus 1 is incoming stocks. Xt is production, and ST is outgoing stocks. Outgoing from this time period. Right? Makes sense. Consumption this period is an identity. It's disappearance. How much was consumed this period? This could be crude oil. Well, how much did we carry in from last period? How much did we produce this period? How much did we carry out? You take the difference, the rest of it's disappeared. It's been used. It's been consumed. And that's equal to C of T. Okay, you with me? Okay. So now, let's write down the price spread that working was interested in. That was P of T plus 1 minus P of T. Right? So that's going to equal F of T plus 1, right? Because we said P of T is F of T, C of T. F of T plus 1, which is equal to C of T plus 1. So C of T plus 1 will equal ST plus XT plus 1, right? We're just adding 1 to our subscripts, minus ST plus 1, minus F of T, which we've already written over there, is equal to incoming stocks plus production minus outgoing stocks. So this term here is equal to C of T. And this term here is equal to C of T plus 1. All we've done is add a 1 to each of the subscripts to get C of T plus 1 as we move from CT to C of T plus 1. So that explains the intertemporal price spread. But we're interested in the relationship between this price spread and stocks. Okay, so we've written down a definition of the price spread. But how does it vary with outgoing stocks? Well, how do you suppose we determine that? Well, let's differentiate this expression, P of T plus 1 minus PT, with respect to stocks carried out of this period. So this will equal, if we use the chain rule, the differential of F of T plus 1 with respect to C of T plus 1, which is in the brackets here, times the differential of C of T plus 1 with respect to S of T, right? Because S of T is inside the brackets, minus delta F of T, delta C of T, times delta C of T, delta S of T, again using the chain rule, right? CT plus 1 cancels, so we've got the differential of this expression with regard to stocks. CT cancels, so we have the differential of this expression with regard to stocks. So that will tell us the relationship between our price spread and stocks. And over here, we started by defining an inverse demand curve. And we know that according to the law of demand, it's downward sloping, right? So this term will be negative, and this term is negative, because that's our definition of a demand curve. So it's a question of what happens to consumption in T plus 1 if stocks carried out of T and into T plus 1 go up. Remember, we're holding everything else constant. So what happens to consumption in T plus 1 if inventories carried out of t and into t plus 1 increase, everything else is held constant, what happens to consumption at t plus 1? Think of the oil example. Okay? We got 2 time periods. We don't change production in the next time period. We don't change outgoing stocks the next time period. All that happens is we build a new facility and we put some oil into storage and carry it into the next period. So what happens to consumption next period? It's an identity, right? There's only 2 possibilities. You might as well guess. Pardon? Don't be afraid to talk. I'm easy to get along with, okay? Don't be afraid to talk. It goes up. Thank you. Yes, it goes up because we're carrying inventories into the period. We're not changing production. We're not changing outgoing stocks. So by definition, it has to rise. Similarly, consumption this period, we said, is equal to incoming stocks, right? It's equal to incoming stocks plus production minus outgoing stocks. So if incoming stocks are 100, right, and production is 100, and outgoing stocks are 100, then we must consume 100, right? We bring 100 in, we produce 100, we take 100 out. So if all of a sudden this rises, right, to 150, we're taking more out of this period, what happens to consumption in this period? By definition, it must fall because we're taking more inventory out. It must fall. So this gives us a negative term here. We have a positive term with a minus sign. So the whole term is negative. Okay? So if we differentiate the price spread with regard to outgoing stocks, it's a downward sloping relationship. So I'll draw that curve and I'll label that D. D is the demand for inventories, right? We started with a simple demand curve. We substituted in a definition for consumption. And now we have this downward sloping relationship that we'll call the demand for inventories, right? In the marketplace for stocks, it's like any other market. There's a supply and there's a demand. Why do you suppose inventories are carried forward in the oil market or any other market? Well, there are market participants who have a demand for those inventories next period. It's like the example we saw on Monday. People in the wintertime are happy that there are entrepreneurs that are willing to carry heating oil from one period to the next. There's a demand for that storage. You want to keep warm. It's true in any market that's storable. There's a demand for stocks. And we see it's downward sloping. Now, does that make sense that it's downward sloping? Well, we can think about the relationship for a second. Again, this is carry-out stocks from period T. So intuitively, I mean, we can see it mathematically. It's clearly downward sloping. But what about our intuition? So just let's do a little thought experiment. We say it's downward sloping. So suppose that the level of inventories carried out of this period fall for whatever reason. What will that do to the price spread? Okay? So the level of inventories carried out of the period fall. What does that mean for consumption this period? Instead of going to 150, it goes down to 75 or 50. What happens to consumption this period? Pardon? It goes up. And in order for consumption to go up, what happens to PT? It has to go down. Thank you. PT will fall, right? Because we're carrying less out of this period. So we've just blown up one of our oil tanks. So we can't carry it out of this period. So there's more oil in the market now. Price falls, consumption goes up. What happens to the price next period? You've just blown up an oil tank. So there's less inventory carried into the next period. It's going to go up. Thank you. It's going to go up, right? So we carry less stocks forward. PT plus 1 goes up. PT goes down. The spread becomes wider, right? So we move from point A to point B. That makes sense. So I think that confirms that the math is correct. It makes sense that this relationship is downward sloping. So one final thing. This demand for inventories is actually unstable. It will move around depending on various shocks as we see. You know, we have production in this period, we have outgoing stocks in next period, and so on. So let's suppose that there's a shock in this period, and if we're referring to the corn market, there's a bountiful harvest. Okay? If we're referring to the oil market, somebody's discovered a new oil well and production's increased. So if production increases this period, XT goes up, what do you suppose happens to that demand for storage? It's going to shift. Which way? Right. Thank you. Exactly. It's going to shift right to D prime if XT rises. Because we have more production in XT, so there's greater demand for carrying some inventories forward. Similarly, if there's a forecast in the frozen concentrated orange juice market, and it says the expected production next period is going down, okay? The report this week, or last week, was the opposite, right? They expected production to go up, but all of a sudden if we get a weather forecast that said January is going to be very cold, so look out, the production of orange juice is going to fall, then the demand for inventories in orange juice would shift to the right as well. Or if we said, let's suppose that the expected carryout for next period rises. So again, there's some information that comes into the market, and we need to carry more orange juice forward into T plus 2, then the demand for inventories in this period will shift right. Okay? So on Friday, I'm going to finish this model. We only have the demand side. I'm going to do the supply side. You will do yourself a big favor if you read Chapter 3, and then you'll be able to follow me in class, because this will likely be on the midterm. So if you just sit there and you don't understand me, that's much more difficult learning it after the fact.